Hello everyone, and welcome to Algebra 2. This is section 6.4 on transformations of exponential and logarithmic functions. Although actually the first 9 graphs are going to be review. We're going to cover x squared, square root of x, and cube root of x. And by doing these, not only will we review, but we'll go over the basic concepts of graphing that carry over beautifully into exponential and logarithmic functions. But as always, there's a lot of this that you can probably do on your own. So go ahead and turn off the video if you can. But if not, of course, I am going to do them for you. So the first step to making any kind of graph is to know the shape. So I see y is equal to x squared, and hopefully you're already thinking parabola. You should also have the parent points memorized, which for the x squared graph are 0, 0, 1, 1, and 2, 4. And because parabolas have symmetry along their axis of symmetry, we can also do negative 1, 1, and then negative 2, 4. And if you can fit it, you can't do it on every graph, then 3, 9, 2, 4, 6, 8. We can fit it. There we go. And this is your basic y is equal to x squared graph. Now shifting, when it's part of the square, it's going to move either left or right, opposite of what you think it will. So this one's actually going to go to the right 3. And a number outside is going to decide up or down, and it does do it the way you think it's going to, so it is going to go up 5. So my recommendation for graphing is to always just keep this one set of points memorized instead of making a brand new table and just shifting your origin. So I'm going to go right 3 and then up 5. And I'm going to pretend that that's my new origin. And then from there, I'll say 0, 0, 1, 1, 2, 4. And on this side, 1, 1, and 2, 1, 2, 3, 4. And that's what that would look like. It really saves you a lot of time to shift the origin first and then keep using these basic points. Now, if you have a number in front of it, that's going to change this table. So all you have to do is y is literally twice all these other things. So I can multiply it by 2 times 2, still 0, times 2 is 2, times 2 is 8. And we're not going to need this one. It's 18, which is too high. Oh, actually, it's negative 2. So times negative 2, we'll make these all negative. So again, I'm going to shift my origin first. This is going to go to the left 1 and up 3, left 1 and up 3. This is my new origin. And now my points are, over here in red, 0, 0, 1, negative 2, and then 2, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And then you can always reflect it to the other side. 2, 1, 2, 3, 4, 5, 6, 7, 8. If you don't want to do all that counting, sometimes people draw their axis of symmetry, and then it's really easy to just do, when you see this one, you can just go to the same spot and go 2 over on the other side, which is a little easier. And then you can draw it. So again, shifting your origin, right? Making your new origin, and then using your A to change your table if necessary. That's what I did here. Makes these problems very easy. All right, again, if you think you can stop this video, you should do that. If not, let's do a square root one. So with square roots, the points that you should have memorized are 0, 0, 1, 1, 4, 2. And the general shape should be that. 0, 0, 1, 1, 4, 2. And if you can fit it, 3 and 9, actually 9, 3, like that. That's your basic shape. So now I'm going to take that and I'm going to go to the left 4 and down 2. And I'm going to pretend that's my new origin. And then from there, I'm going to use these same points. So 0, 0, 1, 1 from this point. 4, 2, and then 9, 5, 6, 7, 8, 9, and 3. No new table. Just think about how hard that would be. Because if you just pick a number like 1, now you're going to have the square root of 5 minus 2. How are you going to graph that? So this method is really great. For the last one, I'm going to take my table and I'm going to multiply everything by 3. So times 3, times 3, times 3, times 3. And it also, you should know the shape, it's going to make it 3 times as tall. It kind of stretches it. So again, my new origin is going to be to the left 1 and up 2. So there's my 0, 0. And then after 0, 0, 1, 3, 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And because that's already 6, I can see I'm not going to make it to 9. But it would look something like that. Next one, square root of, or cube root of x. So this shape is like that. Always know your shape. That's step 1. My set of numbers that I'd like you to have memorized are 0, 0, 1, 1, 8, 2. And then the same for negatives. -1, -1, -8, -2. So 0, 0, 1, 1, 8, 2, -1, -1, and 8, -2. This is the basic parent graph. I'm going to shift it to the right 2 and down 6. So right 2 and down 6. 1, 2, 3, 4, 5, 6. That's going to be my new 0, 0. And then from there, I'm going to go up 1, over 1, and over 8, and up 2. And my screen got a little bit cut off there. But there you go. And on the last one, again, I see that -2, but if you have your basic points memorized, instead of trying to make a new table, just multiply them all by -2. So still 0, -2, -4, +2, and +4. This one has not gone left or right at all, but it is down 3. So there's my 0, 0. And from there, I'm going to go 1, -2, and 8, -4. 1, 2, 3, 4. And then -1, +2, which isn't the real. I mean, real -1, +2 would be up there. But remember, I'm using my new origin. And then the last point is going to be over 8 and up 4. 1, 2, 3, 4. Okay, so let's do that like that. All right, moving on to my exponential graphs. So 2 to the x, this is still review. Remember, the general shape is going to look like this. And don't forget that I do want to see that asymptote, which won't move unless you go up or down. And the parent table is not something you'll have memorized, but you are going to keep it really simple. You're going to do all this shifting afterwards. So this is all going to use the same basic 2 to the x. So anything to the 0 power is 1. 2 to the first is 2. 2 squared is 4. 2 to the third is 8. So 1, 2, 0, 1, 1, 2, 2, 4, and at 3, I'm all the way up to 8. Follow the asymptote, and there's your graph. But now this one goes to the right 3 and up 1. So right 3, up 1. Now the up also affects the asymptote. So the asymptote also went up 1, and this is my new origin. But now I get to use these same points. So 0, 1, 1, 2, 2, 4, and 3, 8. 4, 5, 6, 7, 8. Follow my asymptote, and notice the shape didn't change. All I did was shift it up or down, left or right. But now the shape will change. So on this last one, again, it's 4 times. So I'm going to multiply each of these numbers by 4, unless, of course, it gets ridiculous. Obviously, I'm not going to graph 332. And I still am going to use my new origin. So in this case, I'm going to go to the right one and down 3. Right 1, down 3. I'm going to draw my asymptote. And at 0, I'm all the way up here at 4, 0, 4. And then my next point is going to be 1. So from this origin, this is 1 over, and then 8. 1, 2, 3, 4, 5, 6, 7, 8. And I don't think I can fit the next one. 2, 16 is too high. So it's going to come along and look like that. Okay. Next set. Function with base e. So I only need you to be able to plot 2 points. It has the same shape, so know its shape. That's still one of your rules. And then the only 2 points instead of a whole long list of them are anything to 0 power is 1, and e is approximated by 2.7. Okay, so 0, 1, and then 2.7. And again, I have my asymptote. So it's going to look something like this. Now I'm going to shift my origin. I'm going to go to the left 2 and down 5. I'm going to make my asymptote. And then I'm going to still use these points. So 0, 1, and 1, 2.7. It'll look something like that. Does not need to be perfect. I mostly just want you to know the shape of e to the x and how shifting still applies. On this one, I'm going to make my new origin to the right 5 and down 3. There's my new origin, which means this is going to be my asymptote. And I do see a 4 in front, so now I'm going to multiply this by 4. Okay, so now we got 2.7 times 4. You don't have to be exact here, somewhere around 11. So at 0, it's already up 1, 2, 3, 4. And then at 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that's really just an estimate. I know that 2.5 times 4 is 10, and I know 3 times 4 is 12. So I just took a little rough guess there with 11. I know it's not exact. But look how you can still get a really nice shape and general sense of where the graph is with that one. Next set, logarithmic functions. This is the most recent kind of graph that we did this year. And honestly, as long as you can do this, these are going to be a piece of cake. So y is equal to log base 2 of x is the exact same thing as 2 to the y is equal to x. So make your table using an exponential form and then plug in for y. So when y is 0, anything to 0 power is 1. When y is 1, 2 to the 1 is 2. When y is 2, 2 squared is 4. When y is 3, 2 to the third is 8. Of course, don't forget that even though I plugged in 3 and then got 8, you still have to put it on the graph as 8, 3. 8, 3. So I have 1, 0, 2, 1, 4, 2. And as always, these points don't mean anything if you don't know rule 1, which is to know the shape. And if it comes with it, the asymptote. So I have an asymptote. I know what the shape is supposed to look like, and now I have a bunch of points. I can make a really nice graph with just 4 points. because these are also base 2, I can keep this same table that I made. I'm just going to change where I start. So this one's going to go to the right 4 and then down 3. So right 4, down 3. Here's my new origin. I make my asymptote. I have an idea what it's going to look like, but I'm going to use these points right here. Oops, not 1, 0. Way down here. 1, 0, 2, 1, 4, 2, and I can't fit the 8, 3, so I can stop there. And finally, this one has a multiply by 2 in it. So, ooh, do I multiply the x's now? No, so this is hard for kids. Sometimes people go to multiply the x's because they did those second. But it's that y is twice whatever you got from log base 2. So it's actually still changing the y. So 0, so times 2, times 2, times 2, times 2. This one only moves up or down. So I'm going to move my origin from 0 to 4, 1, 2, 3, 4, which does not move my asymptote. A vertical asymptote doesn't move up or down. So from this new origin, I'm going to look at my red points, which is when x is 1, I'm still at 0, but when x is 2, I'm up here at 2. And then when x is 4, 1, 2, 3, 4, I'm up at 1, 2, 3, 4. And can I fit another one? I think I can. And then over at 8, I'm going to go up to 6. And that's what it's going to look like. So for this next set, e to the negative x, I want you to remember the general shape of any exponential function that has a negative exponent is coming down instead of going up. And it still has an asymptote there, and it still crosses at 1. So once you know that general shape, you really just need one more point. So last time we did 0, 1, anything to 0 power is 1, and then 1 was e to the 1, but now it's e to the negative 1. And I did tell you I wanted you to know e to the 1 was 2.7, but 1 over 2.7? No. So this time, no negative 1. And it will still be 2.7 because e to the negative 1 is e. So at negative 1, it's going to be 2.7. So that's how we'll memorize just those 2 points. It comes down, follows its asymptote, and goes like that. Okay, this next one is actually the trickiest problem of the entire day. And that's because y is equal to e to the negative x plus 2 looks like it's going to go to the left 2. But it actually doesn't. I don't know if you remember, we did one similar to this when we did the square root of negative x plus 2. And I explained then that because that negative affects everything, you have to think of it as negative whatever's in here. So it's actually negative x minus 2. That's what's going to make it come down, or in the case of a square root, go backwards. So we're going to have to rewrite this one as y is equal to e to the negative x minus 2, which means the same thing, but now you can see that it's actually going to go to the right 2 and down 3. So let me just write it also here. So I'm going to go to the right 2 and down 3, and that's going to be my new origin, which means my asymptote still right on the axis, and then the point 1, 0 from here, and remember negative 1e. So negative 1 and then about 2.7. So it's going to come down and look something like that, but very tricky. And the last one, I have to multiply by 4, and I have to move it up 1. So the first thing I'll do is just move it up 1. That's easy. I make my new origin. I make my asymptote. And then I multiply all of these by 4. So 1 times 4 is 4, and you may recall that last time we multiplied by 4, e times 4 is approximately 11 when you multiply it by 4. It's not perfect. Okay, so I'm going to plot my 0, 1, 2, 3, 4, and I can't even reach that negative 11, but just make sure you don't go past that line, and it must come down and look like that. Okay. All right, we've done all the different kinds of graphs, so we're just going to do a few more logarithms and then a few more exponentials to make sure you have it. Again, the key to logarithms is to changing, that means change, that is the Greek delta, is to change the form. So ignore the negative, just focus on the 3. So 3 to the y is equal to x. Step 1, that's the key. Step 2, make a table. Step 3, plug in for y. So when y is 0, anything to 0 power is 1. 1 is 3, 2 is 9. And what this negative is going to do is just think of it as a negative 1 out in front. It could have been any other number out in front. So I multiply them all by negative 1. Now I haven't shifted this one left or right, up or down. So that means I'm still going to get to keep my asymptote right there. But then it's going to be 1, 0, and now 3, negative 1, and 9, negative 2, and it flipped everything. So it's going to look like that. Okay? Sorry, I kind of missed that there. All right. Next one. Now I'm going to use my same chart, but I'm going to shift my origin. So I'm going to go to the left 4 and up 2. Left 4, up 2. That because I went left or right, my asymptote also moved. And I can think of this as my origin. So now there's my 1, 0, 1, 2, 3, negative 1, and 9. So 4, 5, 6, 7, 8, 9, negative 2. So I come down from up there, and I go through those points. Okay? And the last one. Okay, so now there's a negative 2 there. So just because I don't want to cross out numbers twice, I am going to remake my table 1, 0, 3, 1, 9, 2. Same base, so same table. But now I'm going to cross all these off and multiply by negative 2. So negative 2 and then negative 4. And that's going to change its shape. You'll see in a minute. I'm going to go to the right one and down 3. This is my new origin, which means my asymptote, whenever you go left or right, the asymptote has to move too. There's 1, 0 based on this origin, 3, negative 2, and 9, which I can just barely fit, and 1, 2, 3, 4. So I'm going to come down along here and go like that. You see how it kind of stretched it out? It's taller, so to speak, rather than this one flattens out a lot quicker. And that was because of that negative 2 there. All right, last 3. So these are exponential again. When you see exponential, you need to be thinking about that with an asymptote here. Unless, this is why we're doing one more set, these are a fractional exponent. Specifically, it's a fraction between, we'll call it b for the base, between 0 and 1. And what that's going to do to the shape is it's going to have it do this. So it's confusing. There's a lot of very similar shapes that all have certain directions that you'll have to know. So let's go ahead and make our table now that we know what the shape is going to be. And personally, I would actually switch this to 2 to the negative 1 to the x. Remember, 1 over 2 is the same as 2 to the negative 1, and then just make it 2 to the negative x. So much easier. Because then when I plug a number in, anything to 0 power is 1, but if I plug a negative 1, I get 2 to the negative 1, which is just 2 to the 1. And then negative 2 will make 4, and negative 3 will make 8. Really the best way to make that table. All right, let's graph it. My asymptote, I did not go up or down, so it's still right there. 0, 1, that's what we expect on no matter which way it is. But then now negative 1, 2, negative 2, 4, negative 3, 8. So it comes down like that. Okay. This one has been moved to the right 6 and then up 2. Right 6 and up 2. So this is my new origin, and the asymptote moved with it. It went up. If you go up or down on an exponential function, you have to move it. If you go left or right on a logarithmic function, that's when the asymptote moves. So they're reverse, which makes sense because they're inverse functions. All right, but it's the same point, so I'm not going to change anything. So here's 0, 1 from my new origin. There's negative 1, 2, negative 2, 1, 2, 3, 4, and I can just barely kind of reach 10 there. So I come down like that. And finally, I see a 3 in front. That changes everything. So I'm going to take all these y values and multiply by 3. And of course, I'm not going to do that last one of 24. And I'm going to move it up 3. So it hasn't gone left or right. It's just x there, not x plus or minus anything. So I go up, which does move the asymptote. And now I'm going to use these new points in red. So 0, 3, and negative 1, 6. And that's it. That's all I can reach. But I have a really good sense of what it does. So just in case you want to screenshot it, here is your book's explanation of left, right, up, down, reflecting. I kind of like the way I do it, but some people, everybody learns differently. So I'm perfectly happy to have you use these as your general guideline as well. But that's it for section 6.4. Have a great day.